Welcome back to the Science Hub SKB with Miss B. Light, Part 1. The importance of light. What is light? Luminous and non-luminous objects. The electromagnetic spectrum. The importance of light. Light is essential for life on Earth. It helps plants grow through a process known as photosynthesis. It also powers many modern technologies like lasers, cameras, and fiber optics. Understanding light is the key to exploring topics like color, vision, and even the universe itself. Life on Earth, for the majority of organisms here, could not exist without light. This is because light is essential for many biological and ecological processes like photosynthesis, the climate, vision, and behavior. What is light? Light comes from the sun, but it is just one part of a much bigger thing called the electromagnetic spectrum. The electromagnetic spectrum includes all types of light, from the ones we can see to those that we can't. The sun produces 7 different types of electromagnetic radiation: radio waves, microwaves, infrared radiation, visible light, ultraviolet light, X-rays, and gamma rays. Visible light is the only part of the electromagnetic spectrum that the human eye can see or detect. However, we simply refer to the electromagnetic spectrum as light, even though we cannot see the rest types of radiation. So what is light? Light is a form of energy. This is because it has the ability to do work and cause change. For example, light transfers energy to warm the earth and power photosynthesis in plants. Its wave nature carries energy through oscillating electric and magnetic fields, while its particle nature delivers energy in tiny packets called photons, which can cause physical changes. Hence, light behaves as both a wave and a particle. This is known as wave-particle duality. The wave aspect explains how light travels and interacts with the environment, while the particle aspect describes how energy is often carried in photons, which is referred to as particles. Light behaves like a wave because it exhibits properties of a wave, hence it can interfere, diffract, and polarize. It behaves like a particle because it transfers energy in packets called photons. Each photon carries a specific amount of energy based on its frequency, and it can knock electrons out of materials, a phenomenon known as the photoelectric effect. A photon is a particle of light and the fundamental unit of electromagnetic radiation. It is the quantum of the electromagnetic field, meaning it is the smallest possible discrete amount of energy associated with visible light or any other form of electromagnetic radiation. Photons are the messengers of light and energy across the universe. They play a critical role in essential processes like photosynthesis, vision, and solar power energy. In summary, the sun is a supercell nuclear reactor that powers the earth in 7 different possible ways through electromagnetic waves, and we survive because of it. Comprehension. Why is light important? And what is light? Light is important because it powers the earth by warming it, contributes to growing life, triggers weather, powers technology, and supports all systems of survival. What is light? Light is a form of energy. This is because it has the ability to do work and cause change. Comprehension. Which part of the electromagnetic spectrum can we see or detect? And what are some properties of light that makes it a wave? The part of the electromagnetic spectrum we can see or detect is visible light. Some properties of light that makes it a wave are that it reflects, it refracts, and it diffracts. Comprehension. What is a photon? A photon is a particle of light and a fundamental unit of electromagnetic radiation. It is the smallest discrete amount of energy associated with visible light or other forms of electromagnetic radiation. It has properties of a wave and a particle. Luminous and non-luminous objects. Objects which produce their own light are luminous sources of light. For example, the flame of a candle or the sun. Some animals produce their own light as well. These animals are bioluminescent organisms. For example, fireflies, the anglerfish, jellyfish, dinoflagellates, glowworms, and some fungi like foxfire. Objects which do not make their own light are non-luminous sources of light. For example, a book or a desk. Luminous sources enable us to see non-luminous sources. For example, at night, it's hard to see the trees clearly in your backyard. But when day breaks, you can see them clearly because sunlight illuminates the scene and makes everything visible. The electromagnetic spectrum. The electromagnetic spectrum refers to all the different types of light waves, with visible light being the portion detectable by the human eye. The wavelength of visible light ranges from 380 nanometers to 750 nanometers, which falls within the range of human vision. Our perception of color is based on the frequency of the light waves. Different frequencies stimulate the cones, which are the photoreceptor cells in the human eye, in varying ways. This allows us to perceive all the colors that make up visible light. Visible light is composed of 7 different colors: red, which has the longest wavelength but the lowest frequency, orange, yellow, green, blue, indigo, and violet, which has the shortest wavelength but the highest frequency. The electromagnetic spectrum is comprised of 7 types of waves: radio waves, which have the longest wavelength but the lowest frequency; microwaves, infrared radiation, visible light, ultraviolet light, X-rays, and gamma rays, which have the shortest wavelength but the highest frequency. To remember the order of the electromagnetic waves, the mnemonic "Raging Martians invaded Venus using X-ray guns" may be used. Each part of the electromagnetic spectrum affects us differently. Radio waves are used for communication in TVs, radios, Wi-Fi, and they are safe, while microwaves are used in communication and they heat food. Infrared is felt as heat. Visible light allows us to see. Ultraviolet light helps produce vitamin D in our skin. It also gives us tans. X-rays are used in medical imaging, and gamma rays are used to treat cancer. We are exposed to all parts of the electromagnetic spectrum when we go outside, but the intensity and effects vary. Fortunately, Earth's atmosphere blocks harmful high-energy waves like X-rays and gamma rays, leaving us mostly exposed to beneficial or tolerable radiation. However, each type has its risks and benefits depending on the dose and usage. All types of electromagnetic radiation are transverse waves. Hence, light is a transverse wave. Light travels in straight lines. It takes light 8 minutes and 20 seconds to travel from the sun to Earth. Its speed is 3 times 10 to the 8 meters per second in a vacuum. Therefore, it does not need matter to travel. There are 4 important parts of a transverse wave worth knowing. Its crest, its trough, its wavelength, and its amplitude. The brightness or dimness of light that we can detect depends on its amplitude. The colors that light are composed of are dependent on the wave's frequency. A cycle or period refers to the time it takes a wavelength to move. The frequency of a wave refers to how many wavelengths pass within 1 second. The following equation relates the speed of light, wavelength, and frequency. V, which represents speed of wave, is equal to lambda, which represents wavelength, times f, which represents frequency. While this equation shows that frequency is inversely related to time, where f, which represents frequency, is equal to 1 divided by t, which represents time or period. These equations help us to understand what kind of light wave we are dealing with. It helps us to determine its energy, measure what kind of work it can do, and also link light's behavior to time and space. A ray of light is the direction of the path in which light is traveling. It is often depicted as an arrow, while a beam of light is made up of many rays of light. A light beam may be parallel, spreading out, diverging, or getting narrow, converging. Comprehension. What is the electromagnetic spectrum and where does it come from? And how does each part of the spectrum affect us? Well, the electromagnetic spectrum is the full range of all types of electromagnetic radiation, or waves, of electric and magnetic fields that travel through space. It comes from the sun. Radio waves allow us to communicate, while microwaves allow us to cook. Infrared radiation affords us the ability to experience heat. Visible light allows us vision. Ultraviolet light helps us to tan. X-rays are used in medicine, while gamma rays are used in cancer therapy. Fill in the table with the correct responses. Here we have flame, table, plastic bottle, light bulb, a pencil, lava from volcano, fireflies, the moon, a mirror, and stars. And we have to categorize these words or situations into luminous or non-luminous objects. Okay, so here we have all of our objects categorized. In the non-luminous objects column, we have a flame, light bulb, lava from volcano, fireflies, and stars, while table, plastic bottle, a pencil, the moon, and the mirror are all under the non-luminous objects. List 3 organisms that are bioluminescent: a jellyfish, dinoflagellates, and fireflies. How long does it take light from the sun to reach Earth, and what is the electromagnetic spectrum? It takes 8 minutes and 20 seconds for light to reach the Earth from the sun, and the electromagnetic spectrum is comprised of 7 different types of radiation, each of which affects us differently. How many types of radiation is the electromagnetic spectrum composed of? And name the different types of radiation that make up the electromagnetic spectrum. There are 7 different types of radiation that the electromagnetic spectrum is composed of, and they are radio waves, microwaves, infrared radiation, visible light, ultraviolet light, X-rays, and gamma rays. Match the radiation to their respective descriptions. So we have radio waves, X-rays, gamma rays, ultraviolet light, infrared radiation, microwaves, and visible light. Which of these radiation is used in communication in TVs and radios and Wi-Fi? Then which one contributes to tans? Which one causes us to feel heat? Which one is used to treat cancer? Which one allows us to see? Which one is used in medical imaging? And which one is used in communication and to heat up food? Good luck! If you have these answers, yay! Which part of the electromagnetic spectrum can we see? Correct, we can see visible light. Which type of radiation is most safe, and which type of radiation has the longest wavelength and which has the shortest? Radio waves are the most safe. They have the longest wavelength, while gamma rays have the shortest wavelength. What type of wave is a light wave? Longitudinal or transverse? And what is the speed of light in a vacuum? Correct. Light waves are transverse and they have a speed of 3 × 10⁸ meters per second in a vacuum. What is a ray of light? A ray of light is a concept used to represent how light moves from one point to another. It is a straight line that shows the direction in which light energy is traveling. What is a beam of light? A beam of light is made up of many rays of light. What is A, B, and C in the drawing? Correct. A is the crest, B is the trough, and C is the wavelength. What type of wave does the picture depict? Correct, a transverse wave. If the wavelength of the wave is 350 nanometers, what would be its frequency? Use V is equal to lambda times F, where V stands for speed of the wave, lambda stands for the wavelength of the wave, and F stands for the frequency of the wave. Please note that F will be equal to V over lambda, and lambda will be equal to V over F. So if we're solving for frequency, and we see that frequency is equal to speed of wave divided by wavelength, we just substitute these letters for the value. The speed of any transverse wave in a vacuum travels at 3 × 10⁸ meters per second. We divide that by the wavelength, but we have to convert wavelength to meters. To do that, we multiply 350 nanometers by 10 to the negative 9. There we get 0.000000350 meters. And we get a beautiful answer of 8.6 × 10⁻14 per second. Please note that a per second is also equal to a hertz. So we can write 8.6 × 10⁻14 hertz. If it takes one cycle of the wave 0.2 seconds to travel, what is its frequency? Use F equals to 1 over T, where F is frequency and T is time or period. Well, what we would do is divide 1 by 0.2 seconds and we get 5 per seconds. Remember, per seconds is equivalent to a hertz. Hence, the frequency is also equal to 5 hertz. If you were supposed to find time in some other question, please note that T is equal to 1 over F. Thank you for watching part 1 of Light with me. See you for part 2. Bye.